Hello everyone, in the last video we learned about linked list. So in this video we are going to do some important questions of linked list. In the last video we learned about what is a linked list, its structure, disadvantages and advantages, and we saw some basic operations on the linked list. Now coming to our first question, that is count number of elements in a linked list. So this is a basic structure of node in a linked list. Now we have to create a function for counting number of linked list. You can get all the source code in the description box. So we are given a linked list head. So now we are creating a temporary variable to traverse the linked list with temp. Initially the count is set to 0 while temp is not equal to null. That is, while we reach the end of the linked list, we are making the count plus plus and we are incrementing the temp. That is, it is going forward and forward, like it goes +1 and then forward, then while it is not equal to null, then +2, then next element. So this loop goes until linked list ends. So this will return the count of number of elements in the linked list and we are returning the count. Now our second question is to find the middle element of a linked list. So here what we are doing, we are given a linked list with head. So we are creating two nodes, that is slow pointer and fast pointer, to traverse the linked list. So what we will do here is, while the head is not equal to null, that is while we reach the last element, what we are going to do, and we लाइक अगर जो हमारी पूरी लिंक लिस्ट है वो एम्प्टी नहीं है तो ही हम परफॉर्म करेंगे. तो हम क्या परफॉर्म करने वाले कि जब तक फास्ट पॉइंटर नल पे ना पहुंचे और फास्ट पॉइंटर का जो नेक्स्ट है वो भी नल पे ना पहुंचे, तब तक हम क्या करेंगे, फास्ट पॉइंटर को तो हम 2 स्टेप्स आगे बढ़ाएंगे और स्लो पॉइंटर को हम 1 स्टेप आगे बढ़ाएंगे. तो क्या होगा कि जिस पॉइंट पे फास्ट पॉइंटर एंड पे पहुंच चुका होगा तो स्लो पॉइंटर मिडल ऑफ लिंक लिस्ट पे होगा. तो हम क्या कर रहे हैं, जब ये पूरा लूप खत्म हो जाएगा, यानी कि व्हेन फास्ट पॉइंटर रीचेस द एंड ऑफ द लिंक लिस्ट, slow pointer will be at the middle element. So we will return the data of the slow pointer, that is, it will return the middle element of the linked list. So this was the basic function. ये सब practice करके आपको आ जाएंगे. Then what we are going to study is sorting of a linked list. That is, now we are given a linked list and we have to sort it. So now let's see its code. Here we are given a linked list with head reference pointer. So what we are doing is, to traverse it, we are creating a current pointer that is pointing towards the head, and there is also index pointer that is initially null. From the index we are going to create our new sorted linked list. So if the head is null, that is, if our linked list is already empty, then we will return nothing. So, and if there is some linked list, what we will do, that first we are traversing the linked list. So while the current is not equal to null, that is, till we reach the end of the linked list, what we are going to do, we are going to store the next element of current in the index, and now from its next element we are going to traverse that linked list again. So in this what we will check, so while we traverse the whole linked list, we are going to check that if the current data is greater than index data. Now if it happens, then we have to swap the two nodes, that is, the where the index is where is the index and the current node. So what we are going to do, we will store the current data in temp, and current data will now become the index data, and index data will current the temp. So in this way they will be swapped and the linked list will be sorted. So what we are going to do, we are also incrementing the index, and side by side we are also incrementing the current next. You have to be very careful with all the loops. You just have to understand how it is executing. Okay, so this was the whole sorting. That is, using current we are traversing the linked list, and using the index we are traversing the linked list after the current element and checking if they are greater than equal to, and then we are swapping them. Now coming to our next question, that is swap two nodes of a linked list. So here we are given a head that is specifying the linked list, and here we are given two nodes that we have to swap. So what we are going to do, we are creating a temp node to traverse the linked list which is initially at head. So while the temp is not equal to A, so we will traverse the linked list till it reaches the A node. So thus we are incrementing the temp next while it is not equal to A. So now when it has reached the A point, what we will do, we will store the next element of A. The next element of A will become the B next, and the B next will become A. So in this way they will be swapped, and the temp, that is where we just stopped, its next will become the B element. Earlier it was A, but now it will become B element. So in this way they will be swapped. So the next question that comes is reverse the linked list. So we are given a head. So now we are creating three nodes, that is first, temp, and previous, to store the temporary node and the previous node. Initially it is initialized to null, and for the current using that we will traverse, it is initialized to head. So while the current is not equal to null, that is while we reach the end of the linked list, what we are going to do, since we are reversing the linked list, it will break the loop. So what we are going to do, we are going to store the current next in a temporary variable, in a temporary node. So the temp will contain the current next. Next, what we are supposed to do, we are now we have already stored the current next in the temp. So now current next will become the previous element. In this way the link will be reversed, and the previous will now become the current element, and the current will now become the temporary variable. So for this you have to basically visualize that how it is executing, and in the end when all the linked list will be reversed, we are initializing the head to the previous element, because at that time the previous will be the starting of that linked list. So this was all about the reverse linked list. Then we are at a merge two linked list. So we are given two linked lists and we have to merge them. So here we are given the A head and B head. These are the two linked lists. So what we are going to do, we are going to create a temporary node which is initially initialized to A head. So while the temporary variable is not equal to null, that is while we traverse the whole A head linked list, so this will work. Now at this point it will reach the end of the A ahead linked list. So now what we are going to do, we are initializing temp next to the B head. So now the two linked lists will be merged, and at last we are returning the A ahead pointer with the two linked lists merged together. So this was a basic simple operation. So this is our last question in our practice question. So this is to check if linked list is a palindrome. So here we are given a linked list and we have to check if the linked list is a palindrome or not. So here what we are going to do, we are first creating a node that is slow, which is initialized to head, and we are creating a stack here, S. So what we are going to do, while we traverse the whole linked list using the slow, we are going to push all the elements of the linked list in the stack, and simultaneously the slow will become slows next. So in this way the whole linked list will be traversed and all the elements will be pushed into the stack. Now what we are going to check, so while our head becomes null, that is while we reach the end of the linked list, what we are going to do, we are going to store the top element of the stack, which will be actually the last element of the linked list, in the I variable, and then we will remove that element from stack. So now what we are going to check, we are in the starting of the linked list using this, and we are going to check if this data matches the last element. If this does not match, we will return false, and also we will increment the head pointer. So this will go until all the linked list is reversed. If at any point they are not equal, this means it is not a palindrome, so it will return false. But if it goes well and the linked list comes to the end, then it will return the true, that is, it is a palindrome. So this was also simple, just you have to understand the concept. So these are all the practice questions we have discussed, which is count number of elements, middle element of a linked list, sorting in a linked list, swap two nodes, reverse the linked list, merge two linked lists to check if linked list is a palindrome. So you can get all the codes in the description box. Thank you.